This is Honors Pre-Calculus, or just Pre-Calculus, Unit 7, Lesson 8, Convergent and Divergent Sequences and Series. The concept of an infinite sum, adding up an infinite number of terms, and still getting a finite answer is really kind of mind-bending. I can think of one example here. Let's say we have someone at position A and someone at position B. Every second, A travels half the distance to B. So A1 is starting here. A2 would be here. A3 would be here. A4 would be here. A5, A6, and so on. Okay, here's the question that I have to ask for you. Will point A, the person at point A, ever arrive at point B? The answer, obviously, is no. He will never arrive at point B, but he will get so close to B that it is indistinguishable as to whether or not he's at B or not. He is not actually at B because there's always a finite distance between him and B. But we would say that eventually, if we added up all infinite distances that A traveled, that the distance that A traveled would be equal to the distance between A and B. Okay, so that's kind of the idea. Let me give you another example. Okay, well, let's say we've got a square of side dimensions 1. See, 2, 4, there we go, yeah. Side dimensions 1. So 1 unit square. Right? We would say the area of the square is 1. Okay. The area of the square is 1. So here's what I'm going to do, an algorithm I'm going to follow. I'm going to take half of the square and shade it in. The area that's shaded in is 1/2. Then I'm going to take half of what's left. I'm going to shade that in. That's half of a half, or a fourth. Then I'm going to take half of what's left and shade it in. That's half of a fourth, or 1/8. Then I'm going to take half of what's left and shade it in. And you can kind of picture where this is going. Half of an 1/8 is a 16th. Then I'm going to take half of what's left and shade it in. Half of a 16th is a 32nd. And since I can draw it, I'm going to take half of what's left and shade it in. Half of a 32nd is a 64th. Okay? This particular sequence has a finite sum because will I ever exceed the volume of the original square? And the answer is if I add all infinite terms, the sum is going to be exactly 1. Okay? And so we call this a convergent series. Convergent series. Because it doesn't go off to infinity. We're adding infinite number of terms, but it's converging to a finite value. In the case of my walking between two people, A and B, that was an example of this sequence, 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32, and so on. So it's the same series we're talking about with the area of the square. Okay. And so we have this question about how to tell whether or not a series converges or diverges. One of the most famous sequences is something called the harmonic sequence. Harmonic sequence. Okay. In music, it has an application. We call it the harmonic series, right? The harmonic series is a ratio in which you divide the string into one whole string, thinking of the guitar, half the string, 1/3 of the string, 1/4 of the string, 1/5. just to demonstrate real quick here, since I've got my guitar. The whole string, this is an E. I forget what the frequency of an E is. Okay? If I take half the string vibrates at twice the rate, so that is the ratio 1/2. If I take 1/3 of the string on the 7th fret, I get 3 times the frequency of the original open string. If I take the 5th fret, that divides it into fourths, I get 4 times the frequency. There is a fifth. If I divide the string into fifths on the 3rd fret, I can sometimes get a harmonic, but it becomes increasingly difficult to get it to play. So there's application of the harmonic series in music, but the harmonic sequence actually does not, it's difficult to tell, does it converge or diverge? It actually diverges. And the test or the determination of that requires a bit of calculus, so we're not going to go into that right now. So it's not always obvious whether or not a sequence diverges, but when we have a geometric sequence, for a geometric sequence, here's the rule. Okay, the geometric series converges if and only if the absolute value of the ratio is less than 1. Okay? Only if and only if the absolute value of the ratio is less than 1. Okay? If it equals 1, it diverges. If it's greater than 1, it diverges. It converges if and only if the ratio is 1, and is less than 1. Now in the series we have up here, the series that we had for the square, for example, 1/2, 1/4, etc., that can be thought of as 1/2, the first term, times the ratio 1/2 to the power of n minus 1. Okay, that's the nth term of this geometric sequence. And as a series, it converges because r equals 1/2, which is less than 1. Okay, so that's kind of the big idea. We're going to get into some specific formulas for the infinite sum, and we're going to do some limit notation things, but that comes in a later lesson.